but reverting processes. How about this one? We call such a state as transient state. Then I is transient.
Yes, sir.
Correct state and the transient state.
C is non-recurring.
I'm sorry?
F star of I is 0. It's not non-recurring.
F star of I is 0. Okay, so it doesn't mean that. So the chances are low actually that you're going to return.
Yes, sir.
Here for sure, here you are in doubt, maybe or may not. Fi star getting 0 is also a good answer. Why? Because you know you're never going to return actually. Okay? You know for sure that you're going to never return. Those who are going to Mars are never going to return. They know it. They know it. Anyway. So, shall we move on? Okay. What would be the last thing? What would be your wish? So these quantities are interesting. Very interesting quantities. Fij star. Very
Yes, sir.
interesting. From where you want to fetch this information? So you would always like to fetch all new information from
Translation matrix.
translation, transition matrix.
Transition matrix. Yes, sir.
The question is, can I find these quantities from the transition
Transition
matrix?
matrix.
And the answer is yes. You can. Okay. So let me write a formula. This is the first decomposition formula, and it allows you to basically that you can very easily compute if, especially your, Markov chain is a finite state Markov chain. You can very easily compute, these probabilities. But you can very easily know that which state is transient and which state is recurrent if you know its transition matrix actually. Okay. So how can I know it? So that's how I'm going to know it. By the way, what would be Fij of 1? Plus Dij.
Yes, sir.
Probability that you reach from I to j in one step. Okay? I'm writing it explicitly because I'm going to use it again. So let's think about Fij, but in n plus 1 step. Okay? So this would be what? So I can write the probability that x, the chain hits j at time n plus 1 given it was, at I in the beginning. Okay? So we are assuming homogeneity for this. How can I write it explicitly? So in other words, can I say something about, can I write this expression in the terms of, can I write an expression which also talks about the probabilities between 1 and n, not only between 0 and n plus 1, so can I, somehow, so where could be the state, between 1 to n?
It can be anywhere else in the
Could be anywhere
state
else,
space. Yes, sir.
except, what do we call it?
J, except J.
Except J. So I want to write this sum as sum over a state k which is different to j, but we need to make sure one thing, that it must leads to j. It should different to j, but it should be a kind of a state which should be a step towards J actually. Because if it's not a step towards J, it's a kind of a state which doesn't goes to the J, you already know the answer that this is 0. Huh? So it should take you to the J actually. Okay? Times, I can write this as X hits J at n plus 1 given x1 is k and x naught is I times probability of x1 is k given x naught is I. Okay? So writing this probability is a probability of two, conditional probability. Right? What is this guy? So this sum, so I'm not writing it, but we have to assume it, all this stuff is here, is going to be what? So, can you say something interesting about this thing? This is what? This is PIK, right?
Yes, sir.
This is PIK. Can I simplify this expression? Can I simplify this expression? The answer is yes. That, you are talking about a Markov chain, so you don't need this x naught given I. You can ignore it. You can have probability. Okay. Probability. I don't know how do you understand the things that I write, but my sympathies are with you. it's J at n plus 1 given x1 is k times pi, right? That's what is going to be. But what is the meaning of this guy? Can I write it in the terms of f's? One thing I must say, it hits J at time n plus 1, but first hits J. So it's first everywhere, because if you don't have first, you should have first. Okay, so this is nothing but if kj, okay, in how many times? N plus, not n plus 1, but n times multiplied by PIK. Okay? Let me finish it. Let me conclude what we have. Then simplify it. So what did I show? I've shown that if you want to reach from f, in I to j, for the first time in n plus 1 step, you can do it by, going from I to k in one step and going from k to j in the rest of the n steps for the first time, where the k is obviously not j, the sum is over k, and k leads to j. Okay? Next thing. Let's take the sum on the both sides. Okay? So if I sum over the both sides over n, let's sum over the both sides over n. Why? Because I want to, okay, this expression is, itself interesting. Okay? Why it's an interesting, kind of an expression? Because using the transition probabilities and first n step probabilities, you can compute kind of called n plus 1 step probability. So if I take sum over n on the both sides, okay, take sum n equal to, for example, 1 to n over the both sides. I'm going to get a double sum. Okay, Pik and f kj n actually.
Yes.
Okay. What this side will become? I can treat this as, can I say it's f star ij? Okay, maybe you need to
Minus if the first term.
you need to subtract the first term.
Yes, sir.
In other words, you have to add it on the other side.
Yes, sir.
So I can say this would be f star ij, and so what should I add? Pij.
Yes, sir.
Okay, the
Yes,
first
sir.
term. So f1 ij plus this sum. So how can I simplify this expression? So you can see actually that these two sums are on independent indices actually.
Yes, sir.
So if you swap them, it's not going to make any difference. So this sum is over k and this sum is over n actually. So
Yes.
if they would be on the same index, then it's a trouble. You can't just simply swap them. But now you can swap them. So if you swap them and you take this sum inside, so the Pik is like a number, you can pull it out. Then I can say sum over Fn j is actually Fn kj. So what would be this sum? So I can say it's a sum over k, which is different from j,
K leads to
Okay.
J.
times
K leads to J.
k leads to j
Pik
and Pik
and
and f
Star
star
j.
j.
Yes, sir.
That's it. Okay. F star not ij but kj.
Kj. Yes, sir.
F star kj. Okay. This equation is called first decomposition. First step decomposition. First step decomposition. So that's a very beautiful equation. Why it's a beautiful equation? Imagine these f star i's are something that are unknown to you. While these guys are known to you, probabilities are known to you from the system. So what's going to happen if you're going to substitute these probabilities? So you're going to get basically so imagine if I, for example, fix one identity. So if I say, one of the, say if I fix j, for each j you're going to have an equation.
Yes, sir.
Okay. And that equation is going to be a linear equation with these unknowns actually. So what actually you have a very simple system of equation emerging using the transition probabilities, and you solve that system of equation and you get these probabilities. A very interesting probability. Okay. We're going to do one example in the next discussion actually. That basically this is nothing but a system of equation. If you treat these Fij's and Fkj's, these first passage probabilities as unknowns actually. Okay. So the other information that you need is basically this, what is called transition probabilities, which you already know. For example, for a given macro chain. Okay. And once you have these Fij star actually, then you can compute Fii stars. And if they turn out to be 1 or less than 1, they tell you another thing about the state actually, that whether the given state is transient or recurrent actually. So all this analysis, okay, is allowing you to have another kind of a classification of the state. That is that whether each of the state that you have is a recurrent state or a transient state actually. Okay, maybe you have an example, you can, if you wish, you can see it for yourself, otherwise we're going to discuss in the next class.